So today we are going to learn the concept of relation between surface energy and surface tension. Okay. So to understand it, we have to consider one wire frame made up of wire. One small wire is attached to this frame, okay, which can be easily moved like this flexible wire, which can easily slide over this frame. And this complete setup we have to immerse in the soap solution, okay, in the detergent solution. So when we place it, the part up to which the wire is present, it will be filled with a soap film. Okay, in when we were small, that time you had played with a circular shape ring which we used to put in the soap solution, and then we used to blow. So when we blow, the bubbles used to come out. Okay, so you can see when we dip it, it contains one film of soap. Okay, so such way we have to dip it into the soap solution so that a soap film will be formed here. Okay, now let us see what is given here. Consider a rectangular frame of wire P dash P S S dash. This P dash P S S dash. This is a wire frame. It is fitted to a movable arm QR. This QR is movable arm which can be easily slide over this frame. Okay, this frame is dipped into the soap solution and then taken out. A film of soap solution will be formed within the boundaries of PQRS. So when we dip into the soap solution, a soap film will be formed in this complete square frame. Okay, each arm of the frame experiences an inward force of flame due to the flame. Under the action of this force, a movable arm QR moves towards the side PS. This arm will move toward the side PS. Okay, so the area decreases, this area which is there, as it moves toward this. So the area will be minimum, it will decrease the area, and the length of QR is assumed to be L. Okay, now by the definition of the surface tension, what is surface tension? Force per unit length, so F upon L. But this wire frame, if we see this wire QR, this wire QR is both side is in the contact with the film of that soap to the both side. So this length of the wire QR is considered twice. Okay, so the force, that is nothing but tension into length, but here length is nothing but 2 times L, because both the side of this wire is attached with the soap film. So F is equal to T into 2L. Okay, this is our equation number 1. Now what we have to do? Okay, so as this QR, this PQRS is in the contact with the soap film, this QR is under the tension of this force which is acting by due to the soap film. Okay, now if I try to pull this wire to the right side, okay, that is, now this wire is pulled toward this side, and now the next position is nothing but Q dash R dash. Okay, and the distance that is covered is nothing but dx. Okay, so if imagine an external force F that is equal to F dash is applied isothermally to the area QR, so that it pulls an arm away from and tries to increase the surface area. The arm QR moves toward Q dash R dash through the distance dx. Therefore the work is done, and the work done is nothing but force into displacement, that is the force which we have applied to bring this wire this side, and that force is nothing but F dash, and that is approximately equal to the F which tends to keep the wire here. Okay, so what is the value of that force? T into 2L. So just put the value here. So what we get, dw is equal to T into 2L into dx. Okay, now this is length, 2L is the length, and this is a breadth dx. Okay, length into breadth is nothing but area. So 2L into dx gives nothing but what? Area, that is dA. Okay, therefore 2L dx equal to dA. The increase in the area of the two surface of the flame, that is dW, is equal to T into dA. So the work done, now if we integrate, then we get W is equal to T into A. Okay, so work done in stretching the flame is stored in the area dA of the flame as its potential energy. Okay, so this energy is called nothing but a surface energy. So surface energy is nothing but to T into dA. Thus a surface tension is also equal to surface energy per unit area. Surface energy per unit area. Surface tension is equal to surface energy per unit area. So this is the relation between the surface tension and surface energy. Very easy. Consider this frame, rectangular frame fitted with a wire QR, which can be moved easily. You have to dip it into the soap solution. So a soap film is formed. As we can see, the soap film is in contact with a arm QR to the both sides. So we have to consider the length L as 2 times the length L. Okay. Now, by the definition of surface tension, what? Surface tension T is equal to force upon area. So force is equal to tension into area. So F is equal to T into L. Okay, but L, length is again 2 side because both the faces are in the contact. So F is equal to T into 2L. Okay. Now, what we have to do? We have to apply the force here so that this wire will be shifted to Q dash R dash position. So if when we apply the force, that force is nothing but equal and opposite to that of the force which tends this wire to keep here. So that force, when we apply the force, certain work is done so that wire is moved from here to here. So the work done dW is nothing but what? Force into displacement. And what is the value of the force? Value of the force is nothing but this. F is equal to T into 2L. So put this value here. So we get what? dW is equal to T into 2L dx. But 2L into dx, this is nothing but length into breadth, that is nothing but area. So in place of 2L dx, we write here dA. Thus dW is equal to T into dA. So work done in stretching flame wire is then stored in the form of potential energy, and this energy is called as surface energy. So this is the relation between surface tension and surface energy. I hope you have understood it.